Right, so selected review questions. I don't even just have a few picked out. We did 1 and 2 already. And again, all of these are posted elsewhere, so if you want more, you can find more. I just cruised through and circled ones that looked interesting. Number 15. The number of elephants in a preserve is given by a differentiable function e. Selected values of e are given in the table on the right. Approximate e prime at 5. E prime, so that's the derivative of e, or the slope of e, at 5. Well, I don't have any information at 5. But that's okay. I want the slope of e at 5. So which two data points would probably be the best to use to find the slope of e at 5? 3 and 7. So slope of e at 5, I think I can use those. And so that's going to be e of 7 minus e of 3 over 7 minus 3. 34 minus 26 over 7 minus 3. I could safe stop that and leave that as my answer, but I'm going to keep going. 8 divided by 4 is 2. But it also says units of measure. Well, what were the units of measure for E? What is E measured in? Elephants. And 7 minus 3, what was that measured in? Years. So the slope of E at 5 is 2 elephants per year. That gives us the rate of change of elephants. So from year 3 to year 7, they added 2 elephants per year, on average. Like, we don't know exactly what the picture looks like. This is the algebra slope, not the calculus slope. That's why I said approximate. Explain why there must be a time between 0 and 9 such that e prime equals 2. Why there must be a time where a derivative equals something? This sounds like MVT. So I need I need it to be continuous and differentiable. Is it? That's definitely differentiable. It is differentiable. That's given to us. Therefore, continuous. Differentiability implies continuity. So MVT applies, and that means that E prime somewhere equals the algebra slope. And I want E prime to be 2. So I need to find a spot, or I guess 2 spots, between which the algebra slope is 2. Well, they were nice to us. Sometimes you have to go and check and see, well, what's the slope between 0 and 1? That's 1. Between 1 and 3, that's 5 over 2. That didn't work. But we already did this problem. Between 3 and 7, the algebra slope is 2. So we could just say E prime is 2 somewhere between 3 and 7. Because the algebra slope is 2, therefore the calculus slope has to be 2 somewhere. We don't know where. So that's an MVT problem, even though it never said MVT. Okay, here we go. 18, 19, 20, 21, 22, 23, 24, concavity. So here we go. 9 questions, all based on that graph of G prime. And we might end here. We'll just see. The graph of G prime is given on the right. between 0 and 8. Use the graph to answer all those questions. Okay, so this is the derivative of g. This is the slope of g. I don't have to rewrite that, but I'm just trying to get my brain around the fact that this is not the picture of g. This is the picture of g prime. Okay, which of the following is false? All right, so extra careful here. A relative max. Let's see. For a relative max, so in my head I'm thinking relative max. What's g prime doing at a relative max? So don't even look at this. Just tell me in general, at a relative max, g prime is 0, but which way does it change? For a relative max, g prime changes positive to negative. Yeah, it's okay. Use your hands. Yeah, positive, g prime negative, increasing to negative. Okay, so at x equals 4, I need to be careful about marking my graph up because I've got to use this same graph 8 times, so let's be careful. There's x equals 4. Is g prime changing from positive to negative? At x equals 4? Uh-oh, got some yeses and some no's. Like, its slope is negative, but I don't care about its slope. I care about the value, which is positive, 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 and then it changes to negative. So that statement is true. That is weird to wrap your brain around, to look at this picture and say the graph of g has a relative max right there. And you're like, that doesn't look like a max. That just looks like it's some spot on the line. But it's an important spot on that line because that line is g prime, and that spot is where g prime is changing from positive to negative. So there is a max at x equals 4. Okay, we'll speed it up as we move forward here. Relative min at x equals 7. Okay, so same kind of thought process. So there's 7. G prime is changing from negative to positive. So does that make a relative minimum? Yeah. So there is a relative minimum. And again, same thing. Like, your brain has to really be on and thinking to look at that picture and say, there's a minimum there. It's like, that doesn't make sense, except that that's the graph of g prime, not the graph of g. G is a constant from 0 to 2. Okay, if g is constant, what does that mean g prime is? If g is a constant, what's the slope of a constant section of the graph? 0. Is g prime equal to 0 from 0 to 2? I would say g prime is equal to 2, all of those spots. Its slope is 0, but g prime itself is 2. So this one is false. This means the graph of g right here is increasing at a constant rate of 2. Slope equals 2. All right, so there's our false one. G is increasing 0 to 4. Yeah, because 0 to 4, g prime is positive. That means that g is increasing. Number 19. On what intervals is g decreasing? G is decreasing where g prime is negative. So again, be careful what you're looking at. Where is g prime negative? From what to what? 4 to 7. And that's all you need for justify. One of the Facebook group founders, his rule for justify is be brief, be accurate, and be gone. Say what you need to say and get out. Like, I don't want you, justify in calculus does not mean, write a paragraph with an opening sentence and 3 supporting statements and a quote from a certain character. Like, that's not what we mean by justify. We mean give the reason that you know that that's right, briefly, and then you're done. Like, so I don't need a sentence even. G prime is negative, that means G is decreasing. There's my answer. Be brief, be accurate, be gone. At what value of x does G have a relative minimum? Okay, minimum looks like that. So that would be where G prime changes negative to positive. And there's my justify. So now I just need to go where and look and see where that happens. So I'm looking at my picture. G prime changes from negative to positive where? At x equals 7. At what value is G double prime, oh, they even give you a little hint here, the derivative of G prime, the slope of G prime, undefined. Explain how you got your answer. Okay, so that's pretty much my explanation right there. Where is the slope of G prime undefined? 6, yes, I like that. Where else? And 2. Those are cusps. The slope of G prime is undefined at those cusps. Let's see, what is G double prime of 1? Well, G double prime is the slope of G prime at 1. So I would sort of reword the question, because I don't have any information about double prime, but I do have information about prime. So what's the slope of G prime at 1? Careful, what's the slope of G prime? This is the graph of G prime. So G prime is 2, but the slope of G prime is 0. G prime at 3, so kind of the same thing. I want the slope of G prime at 3. Negative 1, just down 1 over 1. 6.25, slope of G prime at 6.25. Where the heck is 6? Oh, so it doesn't really matter 6.25. It's just trying to say somewhere on that piece, what's the slope of that piece? So the second derivative of G at 6.25 is 2. Discuss the concavity of the graph of G. So I would just say, I would answer this, I would justify first. G double prime, let me back up. G is concave down when G double prime is negative. That means when the slope of G prime is negative. If I think through all of that, now I know what to look for. So I like to justify first on all these problems because it helps me know what I'm looking for. So the slope of G prime is negative from 2 to 6. So I'm looking at the slope of G prime, not the values of G prime. The slope of G prime. And then kind of the same thing, G is concave up when G double prime is positive, but I don't really know G double prime, so I'm going to say the slope of G prime, or I could say, this is how Aslan phrased it earlier, G prime is increasing. G prime is increasing from 6 to 8. I don't know. I hope that's helpful, not confusing. I phrased that 2 different ways. You could phrase them both the same way. Slope of G prime positive, or up here, G prime decreasing. Point of inflection, that would be where G double prime changes signs. That's where POI is. Again, I don't have G double prime, so I'm going to rephrase that as the slope of G prime changes signs. So this test is tricky because you have to know all the things, but you have to know how all the things connect to all the other things. So where does the slope of G prime change signs? Careful. G prime changes signs at 4 and 7, but the slope of G prime changes at 6. Well, changes signs at 6. It changes at 2, but it doesn't change signs because 0 is not positive or negative. So only at x equals 6. Okay, that was the main one I wanted to get to. That covered a lot of stuff right there. The other one I wanted to do was 38. The answer is posted. It's kind of the same thing. Here's the graph of f prime. Let me ask 100 different questions about that.